Okay. What's up, everybody? Can you hear me okay? Sound good? Can you see me? I'm pretty. Awesome, awesome. Hey, everybody. All right. Um, Good to see you guys. Good to talk to you. I so it's been crazy. Hope you're doing okay. Hope you're managing through stuff. So I'm gonna talk a lot at the end about, or not a lot, but at least 5-10 minutes at the end to just talk about what is going on, what our class is going to be like, what school in general is going to be like, what and kind of answer some questions because I'm sure you have a ton. I'm sure you've been getting 1,000 emails and all that kind of stuff and Schoology stuff, but I've heard Schoology isn't even working, so I don't know. But I'll talk about that at the end. I'm echoing. Is that true? Can we believe Almond Master? No echo. Okay. All right. Cool. So, yeah. Again, we'll talk more, and towards the end, and I'll kind of open up just questions, not about just math, but just about going forward, what this is going to be like, and what's going on. I'll share as much information as I can, or that I know at least. Okay. But so it's been a really long time since I've talked to you guys. We last left off that I left early for those few days. And I left you with some notes to talk about rational equations, solving rational equations, like for this warm up. Okay. Hopefully, you got my email this morning about that just has these blank notes on it. So that'll be the plan every morning. Is I just send you the blank notes, and then you can work on them with me or while watching the video after I upload it or whatever. Okay. Throughout the stream, if you have a question, just alert me somehow. Just like type in the chat, like question or wait or stop or something like that. Because I know it's kind of hard. It takes longer to type out a math question than it does to raise your hand and say it. So just give me some sort of indication that you have a question, just through a brief word or message. And I try to read the chat while I'm doing this, and I'll pause while I give you time to type something. Okay. All right. Okay. Let's begin our online learning. Woo! So solve the rational equation. So I don't know how comfortable you guys felt with this, with the stuff that I left you on. I know this is tough times that there's no bow tie. Don't worry, bow tie Tuesday will still be occurring 100%. No worries there. So sorry to let you guys down, but it's coming back tomorrow. Promise, guaranteed. Right. So for the rational equation, our first step that we always want to do is just to factor the denominator of everything. So this first denominator, v minus 3, I can't do anything with that. That's already factored. However, v squared minus 11v plus 24, I know I can factor pretty easily in just recognizing that would factor into. So I'm just looking for two numbers, multiply to make 24, add together to make negative 11. So that would be v minus 8, v minus 3. Same thing on the right side with that denominator. It's the same thing. So v minus 8, v minus 3. So my goal is to take this and multiply it, the entire equation, by the LCD, the least common denominator. So I'm going to multiply. I'm going to put big brackets around this so that I know that I'm multiplying the entire thing by the LCD. Okay. So when we're looking at what the LCD is, it's just look at all of the pieces of the factors from your denominator, and just if you see a piece, great, it's part of the LCD. So for example, first I see there's a v minus 3. Great. So that's part of my LCD. Next, as I go over, oh, there's a v minus 8 here. Okay, so I'm going to put v minus 8. And from there, I see that there's another v minus 3, another v minus 8, and another v minus 3. We don't need to do any repeats. Okay, since I already have v minus 3, I don't want to put it again. Since I already have v minus 8, I don't want to put it again. All right, so my LCD is just v minus 3, v minus 8. The music kids there, obviously. Yeah, that's it. Everyone else is just really busy right now in a Schoology conference for their other stuff. So, you know, that's why they're doing other homework, but they'll watch the VODs, the YouTube later. Don't worry. So multiplying this entire equation by the LCD, the v minus 3 and the v minus 8. So this entire thing is going to get distributed to every single term. Okay. You can go through, just to show, you don't have to write this every time when you do these problems, but I'm going to go through and write that whole equation again, just with the actual distribution. So 1 over v minus 3, but then this got distributed from the LCD, plus 1 over v minus 8 times v minus 3, but this got distributed and then 2 over v minus 8 times v minus 3. But this got distributed. Okay, so hopefully you can see from kind of the color organization, the green stuff is all exactly the same from one line to the next. The only difference now is that the blue LCD got distributed to every single term, right? All the stuff that's in there. So after this part, we should always be doing a bunch of canceling, a bunch of crossing out. So when I look at my first term, I see v minus 3 on top and a v minus 3 on bottom. All right, so those are going to cancel. V minus 3, v minus 3, they're gone. They cancel. Okay. And then I'm going to go across and do the same thing in each term. So in this one, v minus 3 cancels. But also, I can see that there's a v minus 8 in the numerator and denominator. So v minus 8 and v minus 8 also cancel. So that's nice. And then in the third term, same thing. V minus 3 cancels. V minus 8 cancels. All right, so there should always be some canceling in this step after we multiply the LCD through. Sometimes a lot of stuff will cancel. We hope for that. It would make it a lot nicer, a lot easier. But sometimes, like in the first term, there's still a v minus 8 up here, but that's okay. So now I'm just going to rewrite what I have left still. So I have a 1 that was left from right there. So 1 times v minus 8 plus 1, which is that 1, but everything else in this term canceled, so it's just the 1, equals, and then there's a 2, but everything else in that term canceled as well. So it turns out v minus 8 plus 1 equals 2. Negative 8 plus 1 is negative 7. Add 7 to both sides. We get v equals 9. Question, why do we not multiply the denominator by the LCD? Good question. So I think probably what you're thinking of is, so let me just make a new page here, is when we're trying to combine fractions together. So like 3/5 plus 2/7. So like we multiply this by 5/5, and we multiply this by 7/7. I think that's what you're asking, where it's like we multiply both the numerator and the denominator gets multiplied by that. So we would end up with 21/35 plus 10/35. Okay. So this is what we want to do if we are looking to combine fractions in some way, like adding or subtracting. Then I can add these together. I get 31/35. But if I look at this, this is still a fraction, right? All I've done is I've taken two fractions and I've combined them together. So that's why we multiplied both on top and bottom. That's not what we're trying to do here. So you can see we're not trying to smash all three of these fractions together into one fraction. Our goal in this place is just, if it would let me write, maybe, get rid of denominators. Are you guys still with me? My computer kind of freaked out. Okay, still here? Cool, cool. Not sure what happened. Okay, cool. So yeah, so in our work here, we're just trying to get rid of the denominator, but we were fine with, we're not trying to combine stuff together. Sorry, is the main point. We're just trying to make sure there's no more denominators. So when we distribute this, we're just doing regular multiplication. And so when we multiply, you can think of this as the LCD over 1. So each denominator is just getting multiplied by the 1. So that's why the denominators just stay the same. But the numerators do get multiplied together. But this is the process if we're trying to combine fractions where we multiply both top and bottom by the same thing. But when we do that, we still have a fraction, which is not, for our purposes in the solving, we don't want a fraction at all. So that's why we're just trying to get rid of the denominators altogether. Yes, that makes sense. Okay, cool. Good question. All right, so I end up at v equals 9. We're not 100% sure if that's the answer because we have to check for what's called an extraneous solution. Extraneous solution just means if I plug in this number, am I going to get 0 in the denominator? All right, because, of course, you guys know by now, we can't have 0 in the denominator. Right? It breaks everything, ruins things. It will freeze my stream if you try to put 0 in the denominator. Don't do it. Well, up here, if I look at all these denominators, if I plug in 9, I'm not going to get 0. 9 minus 3 is not 0. 9 minus 8, not 0. 9 minus 3, not 0. 9 minus 8, not 0. 9 minus 3, not 0. Okay, so I don't care what the numbers are, but the main point, they're not 0. Right, so I've done my check. So I can determine now, yes, v equals 9 is actually a solution. Okay. Hi, Mac. I lost my stream title. Hold on. Let me put that up. College algebra. Day 1. Intro to exponentials. Okay. All right. So I don't really know how well that went with you guys with the solving rational equations. Was it horrific? Did it make no sense just from the notes I had sent? Was it somewhat understandable? Is it better now? Should I take more time in the future to talk more about this? Am I talking to myself? Maybe to all the above. Big maybe. Okay. Cool. All right. Sounds good. Yeah, definitely nice to get a review. It's been a while. I had to spend some time reviewing some calculus over the weekend for sure to get ready for my last class. Okay. All right, cool. Well, then let's go on into our next unit. So we're going to start our next unit, which is exponentials and logarithms. Right. Really good unit. Good times. And there's a lot of stuff we're going to do with this. We're going to do a lot of application stuff, a lot of cool, well, I think are cool, word problems. And actually, for this unit, we'll I don't know. Well, we'll see what like performance task or project type thing looks like, but who knows. Exponential functions, something you've talked about before in Algebra 2, right? And it's so much fun, and I can see, yeah, you love it. So let's just stick to some basics for right now, right? While we get back into things, first day, you know. And an exponential function looks like this, where it's a to the x power, right? But the point is the variable, the x, is in the exponent. That's what makes it an exponential function. Okay, now the a will actually be some number, so 2 to the x, 3 to the x, negative 12 to the x, whatever. But the point is that x variable is actually up in the exponent itself. So that's what makes it an exponential function. So to graph out kind of what this looks like as a few points. So if I think about what happens if I plug in 0. So I have a to the power of 0. Now, of course, we all remember our exponent rules. We all 100% know that anything to the power of 0 is 1. Okay, so every exponential function that just looks like this, where it's something to the power of x, will always have this point, 0, 1. Because whenever you put anything to the x power, to the 0th power, we just get 1. If I plug in 1, well, anything to the first power is just itself, right? It's like multiplying by 1. I don't want to talk about how much money I just had to invest in learning such a fact. It's tough. Not 1. Why did I put 1 there? A, right? A to the first power is just whatever A is, whatever it originally was. 2 to the first power is 2. 10 to the first power is 10, etc. So 1. We'll say this is the point 1A. Who knows what A is? And then on the other side, right, anything to the negative first power. Now here's where I might lose you, right? Because this is actually a pretty commonly forgot exponent rule, right? The exponent of -1 is sort of similar. We don't change A a ton, but it means we can move it down into the denominator. Right, so actually A to the negative first power is 1 over A. So -1 would be 1 over A, some fraction of some kind. Right. So our graph ends up looking kind of like this, sloped slide-like thing, you know how you guys love slides. Wait, don't go to the parks, guys. Don't go on slides. Stay home. That means you, Austin. Okay. So it looks in general like this sort of graph. Couple facts about this graph. Domain of any exponential function, all real numbers. Okay, negative infinity to positive infinity. We can plug in whatever we want. The range will be 0 to positive infinity. And it'll be above 0 because you can kind of see we have a horizontal asymptote at y equals 0. This line going across here will never be crossed. Because there's no exponent we can plug in that will make 0. Right? If we have a number to the power of any number, there's no way it will equal 0. It's impossible. Okay. So this is just our general kind of basic facts about exponential functions. We'll talk more about stuff, but this is just the basics and what that looks like. And so before we do any more of this stuff, we're going to go into just talking about how to solve equations that have exponential functions in them. So, for example, something like this. All right. As we can see for this problem, I have 2 exponentials, right? One on either side. I have the 9 to the 4 minus 2x. That's one of the exponentials on one side of the equation. I have 27 to the 4x. That's on the other side of the equation. And they're set equal to each other. So in a situation like this, what our goal is to make the bases the same. Okay? And when I say bases, that is whatever this number is. Okay, so not the exponent, whatever number that the exponent is on. So right now I have a base of 9 and a base of 27. Well, I want to make it so that they are the same number, right? So that they're either both, whatever. But the point is that they're the same number. So we have to do a little bit of thinking here. And we have to think about 9 and 27 and what we know about them. And if we know of any number that 9 and 27 are both powers of. Okay, so hopefully we recognize that 9 and 27 are both powers of 3, because 3 squared is 9 and 3 cubed is 27. Okay, so using that information, I'm going to rewrite my equation. So instead of writing 9, I'm going to write 3 squared. And instead of writing 27, I'm going to write 3 cubed. So that was the only change that I made. Just instead of 9, 3 squared. Instead of 27, 3 cubed. So now time for more exponential rules that we perfectly remember. So when I'm looking at either side, I have an exponent that is on another exponent of another exponent. So when we do that, we have to multiply. So, and the big thing to remember in this case will be that when we multiply these exponents, make sure that you're distributing if you need to. So in this case, 4 minus 2x, so we need to distribute that 2 to both. For the 4x and the 3, there's really nothing to distribute, but we still need to multiply those together. So this will turn into 2 times 4, 8, 2 times negative 2x minus 4x, 3 times 4, 12x, or it's 3 times 4x, 12x. Once we get to this step where the bases are the same, now we can just completely disregard our bases. We can just look at our exponents, the 8 minus 4x and the 12x, and say, okay, so what number should it be that makes these the same? Because if I already have the bases are the same, so I know both sides of the equation are the same, or they should be the same because there's an equal sign in between them. On one side, I have a base of 3. On the other side, I also have a base of 3. So in order to make this stuff the same, well, it has to be then that the exponents are the same too. So now I'm just going to look at the exponents, 8 minus 4x, and I'm going to set those equal to each other. Because if both sides of the equation are going to have to be equal, then that means those exponents have to be equal as well. So we'll do some solving. Oops. Let me go ahead and add 4x to both sides. 8 equals 16x. Divide by 16. 8 over 16 is 1/2. Right? Yes, exactly, Aiden. Right. So once you get to that point where the bases are the same, it becomes very easy. Because if the bases are the same, great. Just look at the exponents, set them equal, solve. And it's usually not that difficult of an equation. Maybe just, again, don't forget to do some distributing or, whatever. Be careful about negatives. But other than that, not too bad. So questions on this one before I move on? Again, just if you have a question, just say question or wait or pause or hold on or something. All right, so let's turn it up just a little notch, okay, and say, all right, we have an equation, something like this. So 1/6 to the power of x plus 1 equals 36 to the power of 5x. All right. Well, my bases clearly are not the same. right? Right now I have a base of 1/6 and a base of 36. So these are definitely not the same number. Now my goal is, can I get them to be the same number if I just do some thinking about how I can write things? Right. So I'm thinking 1/6 and 36, are they the same power of something? If you have one of these problems where there's a fraction, start off by kind of forgetting about the fraction part. Before I focus on 1/6, let me instead focus for a second just on 6. Okay. So we know that 6 to the first power is 6. I also know that 6 squared is 36. So I'm thinking, okay, well, if it were just 6 and 36, then I'd be great. I know I should make my base 6, exponent of 1 or exponent of 2. Okay, but I don't have just 6. I have 1/6. Okay. So the question of how can I get that? Well, think back to what we did over here. Right? Remember that anything to a negative power will move it down into the denominator. Okay, so that's very helpful for us. So 6 to the first power would still be 6, but if I want 1/6, I can just make sure then that it has a power of -1. Okay, so 1/6 I'm going to rewrite as 6 to the negative first power. And 36 I'm going to rewrite as 6 squared. Right, so the negative is what moves it down into the denominator. Don't forget we need to distribute or just multiply. So -x minus 1 equals 6. 2 times 5x, 10x. Now that my bases are exactly the same, great. Well, then let's just focus on the bases. And we know that the exponents have to be equal as well. So let's just set the exponents equal to each other and solve. Add x to both sides. Divide by 11. X equals -11. -1/11. Right, so a much, not a very pretty answer, but it works. Okay. So the goal is always get the bases the same. Once the bases are the same, set those exponents equal to each other and just solve. If you see a fraction, so like here, let's just go to my next problem. I go to this problem and I see a fraction. I'm seeing 1/25. So when I see that fraction, I'm automatically thinking maybe I'm going to need to use a negative exponent here. Okay. And again, if it helps, before you even think about the fraction, let's just think about, okay, here's this base, and then let's think about 25. I'll deal with the 1/25 in a second. $25, I know, is 5 squared. 1/25, I know, is 5 cubed. All right, 5 times 5, 25. 25 times 5, 125. But I don't just want 25 and 125. I want 125 and 1/25. So instead of having, I guess you guys can't see that a little bit. There you go. So instead of having 5 squared to make just 25, we want the 1 over 25. So we'll just slightly change, instead of 5 to the power of 2, 5 to the power of negative 2. Okay, great. So I have my new base. I know that my base should be 5. So I'm going to use this. So 5 to the power of negative 2 2x plus 3, 5 cubed, 4 minus 9x. We got to distribute. Okay, we have to distribute on both. So negative 4x minus 6. $12 minus 27x. Bases are the same, 5 and 5. So let's just set those exponents equal to each other and forget about the bases altogether. So negative 4x minus 6 equals 12 minus 27x. And solve. Gather x's on one side, everything else on the other. So I kind of combined 2 steps there. First, I subtracted 12 from both sides. So negative 6 minus 12, negative 18. And then I added 4x to both sides. Negative 27x plus 4x, negative 23x. And then lastly, just divide. Negative 18 divided by negative 23. So those negatives will cancel, leaving me with x equals 18/23. So again, same process. Just if you see that fraction in the beginning, just be thinking that you're going to probably need to be using a negative exponent somewhere to help account for that. But otherwise, not too bad. I have another example here. I don't know. Do you guys want to go through it? Or are you still feeling like we should do it together? I mean, obviously you can do it on your own time whenever. Great. Okay. Why not, man? You guys have anything else better to do? I don't know. I do, man. All my friends are texting me, just wanting to hang out and stuff. Sleep. Don't you have to go back to music soon? This stream is sponsored by Hy-Vee, performance-inspired, honest, natural, and better sports nutrition. I just earned $1,000 right there. I wish I had friends. Yeah, you know. All right. So looking at it again, I'm starting off. I see. I bet you in toilet paper. Man, maybe soon. Maybe soon. How do I use my Twitch Prime sub? I can't. Maybe once I hit enough viewers. Right now we're only at what do we got? 11,000. So yeah, so there's only 11,000 people watching right now. But so I think maybe once we hit 15,000, 20,000, then Twitch will want to partner with me so that I can get that sweet Twitch Prime money. How many followers? Key question. 35 as of now. I don't know how many I need. Okay. All right. Let's look at the bases. 16. 1 over 64. I'm seeing the fraction, so I'm thinking probably something with negatives, but I'm going to first just think about 16 and 64. Right. There's actually two different ways we could do this. Right. But I'm going to first start off by thinking 16 I first think of as 4 squared. Okay. Now, maybe you think of it as 2 to the 4th. Because 2 to the 4th power is also 16. I don't know. But I initially think of it as 4 squared. And that's I don't know. I could go through and show you both ways if you want to, but I'm going to stick with 4 for right now. And then I'm also going to think about 64. Okay, so you can, if you don't know, do some testing. Just sit there with the calculator, test some stuff. 4 squared, 4 cubed, 4 to the 4th, 4 to the 5th, whatever. Right. But it is 4 cubed. Is 64. Now, keep in mind, we don't want 64. We want 1 over 64. So let's instead change that to 4 to the negative 3rd power. So just rewrite that same equation. After that, do some good distributing. So 4 to the negative 3 plus 12x equals 4 to the 6x minus 2. And of course, once we have our bases, they match, they're the same. Then forget the bases and just go to using the exponents. Set those equal to each other. Equals 6x minus 2. And solve. So I'm going to do 2 steps in one. So I'm going to subtract 6x from both sides and also add 3 to both sides so that I end up with 6x equals 1. Right. Already no subtraction. Well, that's further than Austin, so that's good. That's great. Good stuff. All right. X equals 1/6. She can teach one of the classes, next next lesson next week. How did the blood class go with the corona stuff? Good question. So I didn't end up having my surgery because of various stuff that happened, but my surgery is currently postponed until next week. But I think it'll get postponed again. I can't imagine I'll end up having it for a while. So I didn't end up getting it done. Sad. Okay, so that's all the math stuff I have for right now. So again, let me just talk about what stuff's going to look like, because I'm sure you have 1,000 questions. I also have 1,000 questions that I demand answers to. So we are having the lead staff is having a virtual staff meeting later this afternoon, and so I'm sure we'll get more answers then about what stuff is specifically going to look like. So I don't have a ton of details. I'll share them with you whenever I learn them, but I do know that PFAs are still going to be a thing. I don't know how it's going to look specifically. I mean, basically, it's going to mean that you're approved to do them at home at some point. Now, I don't know if there's going to be some sort of testing window every day. It's like, an hour or 2 hours where we'll open PFAs and, watch you on Dyno or something, or I don't know, or you'll have to email us notes that you've done to show that you're ready to take the PFA. I don't know. There's been various talk of things, but PFAs will still be a thing somehow. Performance tasks, I don't exactly know. Like when we were going to come back, I was planning on just like having a review and then doing performance task, but I don't really know what that's supposed to look like or how we're supposed to do that. So that's on pause for right now. That's why we're just starting the next unit, and then I'll do whatever we need to do or go back to it, but I'm not sure right now. So other class-wise, I don't really know what other teachers are doing. I know that we're supposed to do, or it's a lot of teachers are using Schoology. I also heard that was down earlier. Maybe it's still down, not working. I don't know. You could probably tell me because I don't try to get on it except in the earlier this morning. But I assume I'm not really sure what other teachers are planning on doing every day or whatnot. But so yeah, I know it's not a ton of information, but that's tentatively what it's going to look like. For those of you that are dual credit, I haven't heard anything from MCC. I'm still waiting to hear from them about what this means or what, anything. I haven't heard anything from them. So if/when I do hear from them, I'll let you guys know. But I mean, I'm just gonna continue on as best I can. So I'll be here, in this time slot to talk about math, and I hope that you guys continue to join me. Again, I don't know that you have a lot of other stuff that you need to be doing, so not many excuses for being busy. But I think the more that are in here and actually listening and watching live or being able to ask questions, then the better. But otherwise, I gave you that YouTube channel link. I'll upload the videos to YouTube every afternoon. So if you just go to my YouTube channel and click playlists, there will be a specific fourth block college algebra playlist, and all the videos will be in there. Again, probably in the afternoon, evening, sometime each day is when I'll put up that day's videos as best I can. If you know how to navigate Twitch, then you can also just go watch the VODs. If you just go to my channel and click videos at the top, and it'll show past broadcasts, and there are also some collections, playlist things that you can see there as well. So I don't know. Do you guys have any questions for me about the class, about school in general, about anything? Do we have any sort of assignments? Assignments, I mean, I'll still send you assignments, if there's a day that I was going to give you a homework assignment, then I'll still send it to you in the morning. Now, well, just like before, I mean, they're not going to count for anything, certainly. It's not part of your grade unless I'm told that I have to do that. And so it will still just be something that you can choose to do on your own and still should do, and you have time to do. um, but I'm unless there's some system that I don't know about, I'm not gonna like have you guys all taking pictures of your homework assignment to then email to me, so that I can look over and check to see. Yeah, because I generally like looking at your homework assignments. You guys know that, but then I just give it back. So um, as of right now, I don't know a good system. So yeah, like Shada just asked, do we need to email our assignments back to you? We could do that, but it seems really messy. It seems really ugly to have, especially for me as the teacher, to be getting 60 emails every day from not just you guys, but if any other classes that I have, and trying to like sort through and find the assignments and keeping track of that. So I don't know. It's not ideal. I don't know. How are we going to do assessments? I'm not sure at the moment, Phoebe. I'm hoping that's something that's talked about in the staff meeting later today, that I can find out more information about, because I really don't know. It might be that assessments are like that, where it's like I send you guys some questions and then you have to take pictures of your work and like email it back to me, or something like that, or you write it on your laptop, however, and then email that back to me. That might be what we have to do for assessments, like for performance tasks. But I don't want to. I would rather not get into doing that like every day for a homework assignment. But that's just my thought right now. I could be told differently at the staff meeting, but I don't know. Good questions. Good questions. What else? What else? Nothing. Okay. Well, hope you guys are staying away from people. Will you continue? Adam Keeler. Of course, Adam. Of course. We have to keep as normal as possible here. So luckily, this hasn't affected Lewis's rugby team at all. So he had no one to play with before. Still doesn't have anyone to play with now that we're practicing social distancing. So that's fine. His life is maintained pretty same. Okay. All right. Well, if there's nothing else, if you do have another question sometime, send me an email. um, or or again, every day, at least the plan right now is every day I'll have office hours still on this stream from 1:45 to 2:30, where I'll just be here available to answer questions. If you have, like if I give out a homework assignment and you have a question about the assignment or whatever, then feel free to pop by and ask. Yeah, or send me an email. I'll try to get back to it as soon as I can. But yeah, otherwise, I'll be back here at 11:30 to 12:30 every day is the plan, and it'll be super fun. So I hope you guys are doing well and staying safe. Hope your family and friends are all healthy and whatnot, and we're doing all the best that we can. But I miss you guys. It's been too long since I've been back at school, and this is gonna be driving me a little stir crazy. So, but all right, I will see you tomorrow then. Have a great rest of your day.